Hi, welcome again. In this particular video, we are going to look at enums and pattern matching. Now, let's dive into enums. Enums, also short for enumerations, in Rust allows you to define a type by enumerating its possible variants. This feature is particularly powerful in Rust due to its strict type checking and pattern matching capabilities, enabling safe and expressive handling of data that can vary in type. Let's look at how to define enums. Now, to define an enum, use the enum keyword followed by the name of the enum and a block containing its variant. So what I mean by that, let's go over a simple example. I'll say enum, it automatically fills up everything. I'll probably not do that. What I'll do is I'll say enum not do that. Once you get used to this, you probably can automatically fill it up. So as I mentioned, define enum, you use the enum keyword and then followed by the name. And in here, what are the different variants? So direction, I can just say there is up direction, there is down direction, there is left, and what's the last one? Oh, right. Yes. So it's pretty straightforward. You give all the variants here. You can keep on giving as many different you want. You can do north, east, north, south, whatever you want to give if you want to do more. Now, enums are useful for defining a type that can be one of the several variants. Each variant can optionally carry additional data than just this. So, for example, I can do an enum with data, which is, I'll say, enum message. And inside here, I can have a normal quit message, or I can have a move message asking a particular object to move to a new location, which is, let's say, I32. Let's keep it simple, comma y I32. So this contains data in here. I can have, let's say, write a particular, so you want to print something, you'll say write this particular string. So I can have a function here. You can also have a change color, and then inside that pass the color parameters. You can just say I32, 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 8 GB values. So if you want to add alpha to, you can do that too. Now this enum has 4 variants with different types of associated data. Now how do you like use, let's look at how to use these enums. Now enums are used to create instances of their variants. Each variant can be treated as a function that constructs an instance of that enum. So let's say if I want to say let message equal to, now I want to use that message enum above, and I'm going to say the value that I want to use is write, and since it needs a string, I'm going to say string from hello. This is how you can use, for if you're using direction, you can just say up down. It's pretty straightforward, but this is how you can create an enum and pass a value. It can be any of these variants that you can use, but I'm using write and passing the string from hello. Let's look at pattern matching, because the match control that we saw before, we learned a little bit about it. If you remember the coin that we created for different types of coins, and we matched it. So the match control flow operator allows you to compare a value against a series of patterns and execute code based on which pattern matches. That's what we saw with coin. It's particularly useful with enums because it enables you to unpack and handle each variant specifically. Let's look at a basic match example with function. So I'm going to just write something outside. I'll say function, let's say process the direction, and then it gets a parameter of, oops, didn't want it to do that, direction is of the type direction. This is where I want to keep that. Now inside this function, I can say match the direction. Now depending on what the user has passed here, or whoever called this function has passed here, if the direction is, oh, this is frustrating something, but I'm saying if the direction is up, which is one of the value, I will say println, and inside that I'm going to say, let's say going up. Same thing, I can repeat this, oops, comma, 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 and comma. So there's 4 different options that we have. So if it's down, left, right, you can just copy this here too. left, down. So depending on if I call this function and say process, and in the direction I say direction up, what it will do is it will call this and print this particular going up, and depending on which I pass, it will do that. So this is how you can call a function. Now match with enums carrying data. Now let's see how can we process that. So for example, we have this enum with processing data. So I'm going to say process underscore message. Since it's message, I'm going to say msg is equal to message. So depending on whatever you're passing to this function, I can say match, and based on what the message is, if the message is, I'll just make it easier, quit, then I can just say oops, print ln, and inside that, since it doesn't contain any data, I just say quit. If the message is move, now move has two data elements, I'll call it x and y, that's what it is. And if that is that, I'm gonna say here move to x at a point and y at a point, and in here I'll pass that x comma y that we get from here. So this is how you can use this. But again, now if the message is the third type, which is write a particular string, for that I'll say, let's say this text that comes out, I can just say text, did I close everything properly here? Yes, text message, and inside here I can give that parameter that I need to pass, which is text. Similarly, the last one, let's say message, the last one is change color, which has three parameters. I'll say R, G, and B. And then in here, I can just say change, oops, change color to R is this one, G is this one, and B is this one, and here I can pass R, G, and B values, which we get from this particular place. So this is how you can match with enums carrying data. Now there's also an option T enum. Rust does not have nulls, but it has an enum that can encode the concept of a value being present or absent with option T. Now the way that enum is defined is it's enum. So let me just move stuff up. So we have space here, option T, you put it in the angular brackets, and inside that I'll say sum T or none. So these are two different values that it has. So this is how you can have nulls in Rust. Now this enum is so useful that it's included in the prelude. You don't need to bring it into scope explicitly. You use option T whenever you have a value that might be missing. Let's see how can we use this. So for example, I can say let some number is equal to sum of, let's say 5, sum t. So it can take any value inside it, any parameter inside it. I can say let some string equal to sum of, let's say, a string, and I can say let absent underscore number, which is option of I32 is none. So in this case, you'll probably see that I can assign some values of any type, because option T can take any value type, or I can also say that it's none, but it has option of I32, which tells it that if there was a value, it would be an I32 assigned integer of type 32. Also, there's if let conveniences that is available for situations where you are interested in only one variant of the enum. If let syntax offers a more concise way to handle values instead of match expressions. So this the way it works is you say if let and then say sum of 3. In this case, sum underscore number is, let's say, println. If it matches the sum let 3 is equal to some number, what it will do is it will say, let's say, print 3, or else it can print not 3. So in this case, what do you think the answer is? So the reason it's going to look at sum 3, some number, and some number is sum of 5. It doesn't match, so it's going to say not 3. If you provide this value as 3 here, it will match it and say, oh, this is 3, so let's println print 3. This code will print not 3 because some number's value was here 5 initially. That's what we had set. Now, enums and pattern matching are among Rust's most distinctive features, providing powerful tools for handling data that can vary in type. By leveraging enums, you can express complex data structures in a type safe way, reducing the possibility of errors. Now, pattern matching with match and if let allows for clear, concise handling of different cases, making your code more readable and expressive in this case. Together, these features enable Rust programmers to write like robust, efficient, and maintainable code. So, if you have any questions on these, please let me know in the comments, and I'll get back to you as soon as possible.